Good morning, everyone. Welcome back. Hope everyone is having a good day. Hope everyone enjoyed last week. Hope everyone enjoyed the video last week. It was an interesting topic, Pythagoras theorem. Not necessarily explained in much depth, but viewed or displayed using C sharp with the script to see what the outputs are. We looked at triplets, we looked at quadruplets, we looked at quintuplets, and I see we're reaching the end of the tether here with what we can achieve with quintuplets. Sets of five, who knows? It's powers of five are large. We're dealing with large numbers, so we're bound to find a few snags. And as we keep on going up in indices, we're going to find less and less solutions. But still, I found it an interesting topic. I hope you did too. I hope you enjoyed it. So today, I wanted to do two more things. I wanted to use the big integer function to allow the use of exorbitant numbers, and then I want to optimize the solution, the script, because we're doing a lot of unnecessary work here. So we can cut out a few steps. So let's first look at big integer first. Um, let's do that. So we can't use big integer without using system, the numerics package, the addition. So we can add that on there, and that won't work in programmers. We can't simply add the big integer there or the numerics. It's simply not there. If I try to do this in programmers, it'll give me an error. So integer how e to the power of 4. Okay, and all I need to do is copy that down for each of them. So a as well, yeah, so a. I need to do the same for b. Okay. Need to do the same for c. Give it some space, and I need to do the same for d. Okay, so add that there. And that's not all I need to do. So I've got, so I'm using big integer. You can see I've got all five for the E4, A4, B4, C4, D4. I'm going to finish that off. I need the if statement. No, I need the if statement. Okay, but I can't use that if statement. So what is this actual sum? If I use the big integer sum, A4 plus the B4 plus C4 plus D4. Yep. And I can shorten that if statement there. I don't quite need it. So I can cut that down to the sum equals E4. All right, so all of that is going to equal our E4, and whatever outputs is the quintuplet. So let's run that again. Hopefully I don't get any issues there. So from 1 to 100. Great, okay, so problems already. It's not going to run for greater than e equals 1. Or at least not easily anyway. So let's come back. Let's move to the optimized version now. Let's have that run in the background. We can run a new script very easily. Well, not really easily. We're going to run another script. That's it. So let's move to another instance of C sharp here. And let's do it. So let's cut that out. So using the system, let me add in all these, instate all these packages up front first, and I will explain what they all are. It's worth noting at this point, I'm not sure exactly which of these packages serve what function. As I was going through them, I didn't quite make a note of it, but all I know is that these were useful, or at least some of them were useful. I don't believe we're penalized in C sharp for the incorporation of unnecessary packages. If anyone knows otherwise, or if anyone can confirm that it does, then please let me know in the comments. I have enough problems with C sharp, or at least my usage of C sharp anyway, so I could greatly do with some tips here. So quintuplets. Quintuplets, okay, that's it. Pythagorean quintuplets. Right. So what is let's up front, what are we doing? So this is what we are trying to solve here. D4, that is it. So geometrically, I think we're a bit beyond the geometric interpretation here. What is a geometric object to the power of 4? I mean, a square is to the power of 2. A cube is to the power of 3. I'm not quite sure what to the power of 4 is. A tesseract, I suppose. For all those who are familiar with the Marvel Cinematic Universe, they talk about tesseracts. The Captain America even was caught saying, "Where is the cube?" But I'm not sure that's geometrically accurate. Tesseract is not a cube; it's a fourth dimensional shape. I digress. Here we are. So the idea is we want to, in essence, what we're working with is four principal loops. So for a to the 4, b to the 4, c to the 4, d to the 4. And how does that combine with e to the 4? So what we're going to do instead is we're going to collapse a to the 4 and b to the 4 into one loop, let's say. So we're going to define up front a sum, let's say a list, a big fat list for a to the 4 plus b to the 4, and we're going to store that in memory. And then we're going to run this over for C and D. And so we're going to link the C and D with the sum of A to the 4, B to the 4. I hope that makes sense. Okay, so let's try this. So const int min E equals 1. Let's use that as the start. Int max E is equal to 1,000. Okay, we don't want to run too many sums of A to the 4, B to the 4. It's still an exorbitant number. Let's not give it too much work to do. So static void main string. Let's bring back that args as well. So I'm going to write a few things first and explain after. So I simply said, yeah, we're going to combine the a to the 4 and b to the 4, and we're going to save that. So what this first, in essence, we're pre-computing fourth powers, right? Pre-computing some fourth powers, not all of them. So great. So big integer. So, all right, so this is where system numerics comes along, and that's as far as the knowledge of these packages. I wrote them down at some point, but I didn't quite get into that, or I didn't quite understand its usage. So max e plus 1, and I will explain why we're doing that. So for int is equal to, I just need to concentrate here while I do this, semicolon I less than the max e, as long as I have something to run over. You'll notice that this automatically indented in there. I don't know why. I have no idea. If anyone knows why the is automatically indented here, then please let me know. So power I power 4. Okay. And you can see this little red squiggly line is indicating that I have to close the loop. That's very good. Programmers didn't allow us to do this, but here we are going to use it. Okay, so there we go. So, okay, so what this is doing here, again, this is simply a means by which we're computing the big integer for everything. It's setting the loop for all of the i's, or all of the a, b, c, d, e. But we want to be specific here, so console write line. So we're going to write this first, building. Remember I said we wanted to sum the a to the power 4 and b to the power 4, b to the power 4, and create basically what is called a function is called a dictionary. We're going to create building a sum dictionary of a to the power 4 plus b to the power 4. Okay. 1, 2, 3, 4, close that, close. And for this, we're going to need this function, the sum map. Okay, so that is new, yeah. Okay, so new concurrent dictionary, yep, concurrent dictionary, big integer. Okay, list. So this is the important part here. So list A. So we're only running this list for B. We only want for now the fourth powers of A and B, or the sum of them at least. So that's what that is. So as I say, this sum map here. That's is the dictionary. That is simply storing in memory. We're not going to keep looping them over. We're going to do that first, and then when we run the loops for D and C and D, we don't need to recalculate it for A and B. We simply can recall those summed values of the four powers of A and B. Okay, so we're in effect collapsing a 5 loop into a 2 loop plus 3 concurrent loops. Or not even 2 loops, so the 5 loops into 3 loops, and then there's the dictionary. So the parallel, what do I want? I've done that, I've explained that. Okay, so now what do I want? I'm going to use this, the parallel dot for, and so there are, I think, what, the 2 points I wanted to mention here. So max, okay, right. So A equals that. Yeah. So four. Let me write this out first while it's still in my head. And like that hasn't come out the way I wanted it. Um, okay. Concentrate. Concentrate. I need that. Uh, that's not that's not what I want. So all right, big integer sum. Uh, okay, equals power for yeah, power of a. Nope. Power of a. That's all I need. Plus the power 4 on b. Okay. Nope. B. Good. In that sum map dot add or update sum. Okay, so new list int. So again, these ints are still referencing the a and b, or at least what now that I'm telling it to. It's, I don't know why is it keep going to argument there? I've done something wrong. I know I've set arguments up here, but I don't think I've properly addressed it. And something I've done something wrong there. I've got 22 issues already, but I'm not sure if those would dissipate if through the course of this if I carry on. So I'm going to carry on. Right. So let me just do that, and I'll address some of these existing. Right. So you and you. So the lock here, lock. Uh, okay, not the existing. We don't want to keep going back over this. So the existings will stay in place. Existing dot add A, B, close that. See, bool again, it's overriding my A's and the B. I don't like that. Okay. Otherwise, return the existings. Yeah, okay. So that's all well and good. Sort of, not really, actually. So something is not right here. There's a bracket missing there. Okay. There's a bracket missing there. Big integer, integer. There you go. That's stupid. E there, no, that is correct for some reason. I'll come back to that. So bool, all right, I've got 5 errors now. B there, that's not good. B is the value I want, but for some reason B isn't being recognized. And I need to close that there, you and there. Okay, good. So I've got 3 errors now. B is not being recognized. Why not? Integer B, A, B. Yeah, integer B. Parallel. Parallel. Oh, silly boy. What have I done? No. Oh, I've got a bit of a problem now. Okay. I'm gonna have to. Yeah, that's it. So, yeah, that's it. Because I didn't even run this. So for integer, b is equal to a, is equal to a. B is less than the max e b plus plus. There. So I think that should get rid of some of our problems here. So I need to move that. Uh, get rid of that. Get rid of that. Get rid of that. Okay, and now I need to end that there. Okay. Good. So, all right, no issues found. We're good. We're at parity now. So, few things. Few things. So, the parallel up here. You notice that I've haven't closed the loop there, but I've closed it down here. Um, the simplest explanation I can find is that the parallel for is not a simple loop. It's a method call, which means that the argument is not a simple few lines of syntax or a few digits of syntax. This is the argument that I need for the parallel for. So I'm leaving it deliberately open-ended without the bracket there, and it'll be finished right down there. Um, so the second thing is that max e plus one. So the max e plus one. So the max e is 1,000, but I don't want it to run to 1,001. What's happening here is that the parallel for and some other functions, which I don't remember, is indexing from 0. So not 1, but 0. So even if I wrote, let's say, I don't know, 50 up there, the index is still 0, and it'll cycle through all the values from 50 to 1,000, but starting from an index of 0. So what's going on with this 1 is that the final digit that it would run to, or the range would be 0 and 9999, 9,999. To counteract this, to move it forward, I'm simply adding the 1. Okay, good. Let's move forward now that I've sorted that out. Thinking. Yeah. Okay. So what's gonna happen now? I'm missing something here. I need to move all that forward. Wait. No. Okay. I'm pretty sure. Yeah. I need to bring that there. I mean, it doesn't matter. It's still run anyway. Four. Yeah. One, two, three, four. Yeah. One, two, three, four. One, two, three, four. One, two, three, four. One, two. Oops. One, two, three, four. Okay. Good. 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 Okay. So while that is running, we have set up the dictionary for the fourth powers of A and B. What's going to happen now is that we need to search for the quintuplets. Searching for quintuplets. Quintuplets. And that's going to run in the background, as in it'll say that it's running in the background, or it will be running in the background. So good. Okay, so what do I need now? So var scene equals, and this is where we add the concurrent dictionary. Again, dictionary. What is that? It's a string bool. Okay. Yep. Trying to think, what is that? Um, it's worth pointing. The concurrent dictionary is a way. The concurrent dictionary is a way of allowing new entries to be added to the dictionary. So not simply A to the four and B to the four, but now we're doing the same for the whole structure. For C and D, we're adding C and D now, the parameter C and D. So whenever we get, let's say, new quintuplets, we're adding that easily to the concurrent dictionary. If we didn't use a concurrent dictionary, we're losing robustness. It's going to be very difficult to add these solutions and store them. So now I'm gonna end this. So this is where mini. Oh wait, no, mini. Stupid mini. It's getting my way. Minimum E, max E plus one. E is greater than. So notice that we're going to do the exact same thing, leaving that open-ended. It's not going to like it for now, but it will have to get used to it. So then the big integer, this is where we add in the C and D parameters now. So power of 4 and E. Okay, and we want to run that a new loop, or introduce the two new loops for C and D. Okay, so C less than E, and C++, C sharp, C++, for int D equals C, D less than E, D++. Okay, so there we go. We've had the sum dictionary, and now we're simply completing the expression here by running it for C and D. Good. So I've got 4 issues here. Why do I have 4 issues? I mean, yeah, because we still haven't closed the expression. We still haven't actually done anything. That's not a good way to say this. Okay, so now what is it? So let's define that sum, or define a sum for CD sum. So what is that? That's going to be the fourth power of C plus the fourth power of D, right? A simple sum for the remainder of the expression. And now we want another big integer sum, and this will be the aim. What are we actually aiming for? So this is e to the 4 CD sum, okay? So again, we've got that CD sum, which is this second half of the left-hand side. And in essence, what we're trying to do is that we've got an E4 minus CD sum. So we're going to try and target, again, the A to the 4, B to the 4. Again, linking it up to here. So whenever that, basically the target is 0, we have a quintuplet. Okay, so I can continue on further. So I'm not adding that, it's adding the sum map. Try get value target, target out var AB list. Okay, and so what that is doing here, the AB list is referencing, or in C sharp, the AB list is shorthand for that. So remember, this is the sum for the fourth power of A plus the fourth power of B. So we're trying to get the values of the AB list. Okay, so I'm almost done. I appreciate we're heading for time here. Not that we actually have a time limit here. I tend to well, not make these up as I go along, but there simply is no time limit. But ultimately, I wouldn't want these to go on for too long. That's always the aim, and as you can see, it doesn't quite end up that way. Okay. In the AB list. So finding the AB in the list if we do actually have a quintuplet. Okay. This part here is very important. I think this is one of the key few lines here that increases the robustness, or at least streamlines all the efforts. So A, B, C, D. Close that. Yeah, you're telling me. You're telling me. Yep. Okay. The array dot sort values. Okay. Okay, so I've still got two errors here. What's going on here? The int values for the remind myself, what did I do with that? Yeah, the a int values here. Um, so recall before with the case of quadruplets, Pythagorean quadruplets. I don't think Pythagoras himself got there, but we had this case here, 3, 4, 5, 6, which was a solution to the quadruplets. However, what about other such ones like 5 and this, no, 5, 6, 3, 4, I don't know. So that is also a solution, but we're sort of doubling the efforts by adding in a new one. So 5, 6, 3, 4 is a permutation of this solution, which we already have. We don't need to write it again. These two, they're the same. So this is what it's doing. This is what these two lines are doing. The sort is arranging 5, 6, 3, 4 into 3, 4, 5, 6, and it's adding it back to this concurrent dictionary here. So it's going to add it anyway. So I need to do one more thing, and that's where this string key equals values is. Okay, so this is recognizing it as a value. It's turning it into a string. It's not storing it as digits, but when you store things as a string, it's a lot easier to manage. Scene try add key. Where did I see it for? You saw me struggle with this key when we were dealing in episode 3 with stereographic projections. Key, lowercase letter. Okay, what was the point of that? Why am I telling you that? For no particular reason. That's it. The string key is storing the 5, 6, 3, 4. No, the 3, 4, 5, 6 is the string. The try add is basically saying if we already have it, ignore it. So do we want to add it? If we already have it, true, add it. If not, false. Okay. So I'm almost done. Lock console dot out. Okay. So I wasn't entirely sure what the lock was for, but it's locking the permutations when we're working with a to the 4, b to the 4. That sum, and so it's locking that every time we try a new combination of c and d. Okay, right line, and I'm going to end this. So this is the actual output here. Okay, so what is it? I need to output a equals. I need to output everything. So a values 0. Okay, and I'm going to copy that, and I hope you can see why, because I don't want to have to keep writing it again. That's right, 1. Okay, c equals values 2. So yeah, I need the hold on, d equal to values. I didn't need to do that. Conjunction if is not needed here, and e is equal to e. Right, so what is it? I have 18 errors. Goodness, what have I done? And how do I fix that? 17 errors now. Okay, hardly any better. So let's see now. Okay, no, well, that's it. That will be okay. Get rid of that. 2 errors. Okay, so console. Okay, so now I need to close that. So remember, I'm still using parallel 4, which is the method call. So I need to close that. Where are you? Down here. You can see the lines. These are really good. Okay, no issues found. That's great. However, okay, all right. So once this is all done, yeah, let's give another message there. What do I want? Search complete. Completed. So I think we're fine. No issues found. I mean, if C# says we're fine. Yes, quintuplets. It's not going to tell me if there are spelling errors, so I'm going to do that again. Pre-computed 4 powers. Let's go. What do we get here? Oh, it's running. It's running. There we go. Here we go. Bringing some forth. Searching for quintuplets. There we go. Oh, there's one. There we go. Any more? There's 2. There's 3. Great. I don't. Probably wondering why I sound so surprised. I ran this a few days ago, so I know what the result is. But that's really good. I'm really pleased with that. We've got three quintuplets there. And by doing few things there. So we've got the can I bring that back? Yeah. We've got yeah. Yeah, it's all right. So we remember, first thing, we collapsed the a to the 4, b to the 4 into one equation. We removed the duplicate permutations of the same combination here, storing that as a string. That really helped too. Um, and then again, we're really running it over these two loops here, so C and D. So that's all well and good here. I'm really pleased with that. So I don't know if you can tell. So the system collections concurrent. So the second and the fourth package that you see up here, they're highlighted in like a white font, where the other three are highlighted in a grayish font. I don't know why. Maybe that's they're telling me that those are the only useful ones I needed. If I don't know, if I delete these three that are not needed, who knows? Um, anyway, I'm pleased with that. I'll leave that for now. It might simply throw the error if I do that, but I don't know. We've come this far. Let's do that anyway. No issues found. Still no issues found. But if I run that, what's going to happen? Pre-computing, searching. Okay, fine. I guess. Well, there you go. There you have it, guys. I mean, I guess we didn't need those three packages. I was screwing around there for nothing, trying to figure out what it is. So anyway, so that was the optimized attempt. Let's go back to the non-optimized attempt with the five concurrent loops, and see what we did here, what progress that is on, and we are not on any progress. This have not advanced, has not advanced beyond equals one. So let that be a lesson that any time you decide to do loops like that, as I did, I tried to do this, or I did it, and I mean, yeah, it did it because it was a simple solution, but it's not practical. So I think what's going on here, it was here, this parallel four, I think, is also quite important. And what it's doing is it's sort of splitting up the work across multiple CPUs. The best way I could describe it is if you had, let's say, 100 tasks, or let's say five tasks, so the five different loops, but you're running that all on one processor, or the CPU. So I had the five loops for A, for B, for C, for D, for E. But if I spread those five loops, instead of over one, but over five processors, now let's say altogether those five loops ran on the one processor at, let's say, I don't know, 100 seconds. So if I were to run those over five processors, I might have this all run in 10 seconds, because that's how long each of the loops took to run. Uh, okay, and that's pretty much that. I'm really pleased with that. So there you go. Those are solutions there. Maybe we can prove that. Maybe there's a way we can. These are large numbers. We're working with to the power of four quartics here. So maybe there's a way we can prove that. So for now, I'm still not done on this. There are a few more things I want to work with here. I want to test out a few more expressions, scale it up maybe to another index. But you can see quintuplets, sets of five, a set of five integers is, we're getting into some problems here. Maybe that's it. Maybe we get to six tuplets. I don't think that's the word. Six tuplets. We might get into some problems. But for now, I'll use this script as a basis of moving forward. But for now, yeah, if anyone has any questions, let me know. I hope you've enjoyed this. And if you have any comments, questions, criticisms, I'm always happy to hear it. I'm always open to suggestions. So please let me know. And I'll come back next week. So what is it? It's September. It's September 1st, 2025, Monday. And so next week we will do some more things. I'm not finished here, and I hope you're finding this interesting. So thank you very much, everyone, and we'll see you next week.